Bismillah ar-Rahman ar-Rahim. Inshallah, we'll do some exercises in 2.3. So let me start. This is the file which we shared with you. Just a quick review about what we have in this section. We have the main limit rules or roads. The limit f of x is goes to a exists. Limit g of x is goes to a exists. Both exist. Then their sum is equal to the sum of the limit. Their difference is equal to the difference of the limit. The constant times the function. You can take the constant outside. Product is the product of the limits. Limit of the quotient is the quotient of the limit, provided you know the limit of the denominator not equal to 0. Direct substitution. Most of our functions, especially the functions they are continuous, which is we will do in 2.4. For example, polynomial or rational function, and a is in the domain of f. Finding the limit is like the substitution. One of the most important things about the limits, if two functions are equal, except at one point, then their limits at that as x goes to that point should be the same, provided the limit exists. For the rational function, you need to consider 4 cases. If you have, when you do substitution, you get non-zero over non-zero, خلاص, you just substitute. If you have 0 over non-zero, then that is 0. If you have 0 over 0, usually this is the most important one, where we call it undetermined form, غير محدد, and that means you need to do something to fix it. So this case, it will be either this, let me call this case 1, this case 2, this case 3, this case 4. Case 3, it will be one of these 3 cases, 1 or 2 or 4. So you need to do something, you need to manipulate it, undetermined. So you need to do something to fix it, and then it will be changed into either one of these cases where you will get the result like by substitution, or it will be non-zero over 0, which is like an infinity category. It will go either to infinity, minus infinity, or does not exist. As I said, in this case, we just substitute. You just substitution, nothing else. In this case, the same thing, but when you do substitution, you're getting 0. So in this is direct substitution, these 2 cases. In this case, you need either to factor or simplify, rationalize. You need to rewrite the function in a different way. For this case, as this goes to a from right or from left, it will be either infinity or minus infinity. But the limit as this goes to a, then like in this case, if it goes to 3 from right, you'll notice it's a non-zero over 0. So it's an infinity category. We call it infinity category. Since it goes to 3 from right, check the sign here. They are positive. And the sign here, as x goes 3 plus, means more than 3. That will be positive also, but it will be plus infinity. So the answer will be plus infinity. However, in this case, if you notice it, 3 from left, which is a number less than 3, that will be positive. But this will be a negative value, but it's an infinity category, so that will be minus infinity. Okay. Now, non-zero over 0, then we are talking here in these 2 cases about the limit x goes to a from right or left. But if we deal with limit x goes to a, like x goes to 3, since one of them goes to infinity, the other one goes to minus infinity, so the limit x goes to 3 will be does not exist. This is the just in words, the same thing, the three cases. For the greatest integer function, you need to notice something. You check the things inside the greatest integer, inside the function as inside the greatest integer. You substitute the a, you check f of a. If f of a non-integer, خلاص, then direct substitution, the limit either from right or from left will be the same, and it will be just substitution. So you get the limit. However, if like this example, check inside, there will be 1 minus 5 over 2, which is minus 3 over 2, which is an integer. خلاص. Then this limit, just a substitution. Like if we do substitution, it will be getting 0 minus 3 over 2, which is minus 0.5. We also have what's called the squeeze theorem. What's the meaning of the squeeze theorem? If you have a function where you can squeeze that function between two functions, f and gh, and the limit of these two functions, as this goes to a, is equal to the limit, they are equal. The limit of these two functions are equal, call it to L. So the limit, the one in the middle, should go to L also. Okay. As we said before, most of our known functions, when they are continuous, this is we'll do in 2.4, finding the limit is just substitution. Okay. Polynomial, rational function, radical, provided everything is defined, so you can do that. Composite function, if the function is continuous, then you can, to find the limit, you can take the limit inside, provided the limit, this limit exists, and the function is continuous. We'll do that again, 2.4. These functions are continuous in their domains, so finding the limit is like substitution if C is in the domain of these functions. And for example, I need to be careful here, X should be positive to find the limit. I mean, yeah, so we mean C here should be positive. If I want to find limit, X goes to 2 of ln X, since 2 is in the domain of this function, so you just substitute, you get ln 2. If we get 0 over 0, there are some strategies. Mostly they are depends on this, that the limit, if the two functions, as we said before, if the two functions agreed except one point, then, and the limit of g of x approach C exists, then the limit of f exists and it's equal the limit of g. The limit will be equal. How to do that? Either you do factoring and you do cancellation. Since they don't agree at one point, you can cancel that. Rationalize, simplify, squeeze theorem. These are some of the things. And we have 3 special limits, which is this limit, and this limit, and this limit. Okay, that's mainly what we have in this section.